Welcome back. In today's problem, we're going to calculate the energy and the average power for the signal x of t. In this case, we know that we have three classification. This signal has the classification of having infinite energy. This is because we don't have a unit step function or a step signal bounding or signal x of t. And we know that cosine t is a continuous time signal. It goes from infinity to negative infinity or negative to positive infinity. Thus, the energy for this signal is going to be equal to infinity. We know that because if we integrate a signal over a finite interval, we're going to have a finite amount of energy. If we integrate over an infinite time interval, we're going to have an infinite amount of energy. This is a second class of signal that says if we have an infinite amount of energy, the average power for that signal is greater than 0. In this case, we already have the energy. So we can say the average power is equal to the limit at which t approaches infinity. And that will be E, the energy, over 2t. In this case, the energy for the signal is infinity. And as t approaches infinity, we have the average power is equal to a half, which we know that is greater than 0. What if we did not know or remember that remember the classifications of these signals? In this case, we would have to evaluate the expression, the cosine for that signal. In this case, we know that we want the magnitude. So the I components or J components, whatever you're using, is going to equal to 1. We know that cosine square, the identity for cosine square will be 1 plus cosine 2t all over 2. Thus, if we integrate that, we can factor out a 1/2, integrate 1, we get x, well, in this case, t, and it's going to be added to the integration of the cosine 2t, and that's going to equal to 1/2 sine 2t. And if we evaluate that expression, and before we evaluate, we can put that together, and that would be t plus sine 2t all over 2 infinity. And if we evaluate that from negative infinity to infinity, it will always converge to infinity. This is because the exponential form of sine is e to the, in this case, 2t. Remember, the j components are 1 because we're taking the magnitude. We are evaluating the magnitude of the signal. That's minus e negative 2t all over 2. And remember that is in the numerator of the expression. So thus, for this signal or this expression, we know that e to the negative infinity, say this portion, e to the negative infinity is going to converge to 0, but then 0 over 0 divided by 2 is still 0, and for positive infinity, it's going to converge to infinity. Well, long and short of it, just let's do that. So in this case, if you evaluate infinity first, that is going to be infinity minus 0 over 2. All of that is going to minus for negative infinity. That's going to be 0 plus infinity all over 2. And as you can see, infinity minus infinity is still equal to infinity. And thus, this is why the energy of that signal is equal to infinity. And if you evaluate this expression for the average power, you get infinity. And still, we have 1 over 2t, and we times that by infinity, infinity, and as t approaches infinity, we'll get 1/2. That's it. So see you in the next problem. Bye.